Hello, everybody. Welcome to the next week of e-learning. Today, we're going to talk about acid rain, which is a particular effect of certain kinds of pollution. Okay, it's come up before. I don't hear as much about acid rain as we did actually about 20 or 30 years ago. Acid rain, as horrible and destructive and problematic as it is actually an issue that gives me real hope for the future. And if that sounds strange, well, I'll explain what I mean as we go here. Okay. So let's first review what an acid is. Okay. Normal precipitation, normal rain, snow, anything like that has a pH between 5.5 and 6. Okay. So very, very slightly acidic, not so that you'd notice at all. Anything that's much more acidic than that, anything that's a pH of about 4.5 or so, is considered to be acid rain. Remember that a pH of 7 is considered exactly neutral. That's totally pure water. So actually, regular rain is not completely pure water. It has a few things dissolved in it usually, which makes it ever so slightly acidic. But when we start to get a pH of below 4.5, somewhere between the pH of a tomato and the pH of a banana, then we start calling it acid rain. Now, acid rain is a terrifying sounding term. We're not talking about something that will like burn your skin if acid rain falls on you, okay, or burn your eyes or anything. It's not generally that acidic. Okay, we're talking a pH of around 4, so around tomato juice or so. Now, in extreme circumstances, it can be much more so. The record pH for acid rain in the United States was 1.5, which is extremely acidic and potentially dangerous. But that level of acid rain is extremely rare. Okay, so this is what we're talking about. Rain, or actually any kind of precipitation, snow, anything like that, that is more acidic than usual. Okay. Now, rain is most common, so we call it acid rain, but any kind of precipitation counts. And it is possible for pollutants, the acid, to fall without water. We call this dry deposition. So this would happen particularly in desert environments or things like that, where there isn't a lot of precipitation. The pollution of this type can still fall without the precipitation, though it's not as common. Okay. So it's caused by a couple different types of chemicals: sulfur oxides, and it's also caused by nitrogen oxides. Okay, these are types of air pollution. Sulfur oxide generally comes from burning coal, which we would usually think of these days, at least, as being from power plants. Okay, there's a little bit of sulfur in coal, just as a kind of contaminant. And when we burn the coal, that sulfur is released as sulfur oxide into the atmosphere, where it can cause acid rain. The nitrogen oxides generally come from car exhaust. Okay, there's some nitrogen contaminants oftentimes in gas, and especially in diesel. Diesel can also have sulfur in it. And when these are burned, they produce nitrogen oxides, and in the case of diesel, it can produce sulfur oxides. Okay? In fact, if you drive a diesel vehicle, so you ever pay attention when you're buying diesel at the pump, you'll notice that what's sold for highway use, at least, is called ultra low sulfur diesel. In order to be sold for highway use these days, or for driving on the road, not for farm use these days, the diesel has to be ultra low sulfur. And it's because of this issue of acid rain. Okay? But these chemicals, the sulfur oxides and the nitrogen oxides, when they get into the atmosphere, they dissolve in the water up there in the rain, and they form, either if it's sulfur, it forms sulfuric acid. If it's nitrogen, it forms nitric acid. Now, these are extremely strong acids. Okay, sulfuric acid, nitric acid, extraordinarily strong acids. I mean, typically, of course, what comes down in the rain, it's mixed with a lot of water, but they have the potential to be extremely strong. Okay. And so, what does this actually do? Well, for one, it's an acid. It dissolves things. Okay, this statue here, these are two pictures of the same statue. I believe it's in Europe. But the statues like this, made out of marble or limestone all over the world, After a couple decades of acid rain, you can see it's completely, the face, all the features, all the detail have completely eroded away from the acid in the acid rain, eating it up. Okay, or even buildings. Okay, the exterior of buildings made from these kinds of stone can be eaten away. Okay? Now, of course, this acid is not good for plants. The acid can attack leaves. It can build up in the soil, make the soil more and more acidic until it kills off the plants. Okay? So here is an old forest. It's downwind of an industrial area in Germany. This happens to be in Poland. It's just over the border into Poland, where for many decades in eastern Germany, there were coal power plants and factories and things that were churning out sulfur oxides that then caused acid rain to fall in southwestern Poland, and it killed off all these trees. Now, you can see there's new young trees growing in more recent decades. That air pollution has been much more heavily regulated, and the pollution has basically stopped, and gradually the forest has begun to grow back. But these dead trees are still standing there from decades ago when they were killed off by the acid. Okay, it can build up in water, make lakes, streams, rivers more and more acidic. Okay. Now, the fish themselves, the adult fish, in most species are able to tolerate some acid, but the eggs actually can be very vulnerable to acid. Fish eggs, have you ever seen fish eggs or frog eggs or things like that? They don't have a shell. Okay, they're like jelly. They're just exposed to the water. So they're not protected from any sort of pollution or acids in the water. They're extremely vulnerable to anything in the water like that. And as the water becomes more and more acidic, it eventually, depending on the species, it reaches a point where the fish eggs are no longer able to survive. The adult fish can survive, but the eggs can't. Well, after a few years of the eggs all being killed off, eventually you won't have any of those fish left. What this graph shows is that different species can tolerate different levels of acid. Okay, so according to this, at least bass eggs can tolerate levels down to between 5.5 and 5.0. Anything below that, they cannot survive. Okay, and different species will be different. All right. Now, brook trout. They used to be common in like New England. The Adirondack Mountains are in kind of upstate New York. It was a popular vacation spot for people who lived in New York City. Well, over many decades in the 20th century, Indiana, Ohio, Michigan, Pennsylvania, had lots of factories, steel mills, and things burning lots of coal, a heavily industrialized area. And acid rain from these states fell in New York and basically killed off the brook trout in the Adirondack Mountains. Okay? So it has heavily affected the tourism industry, the fishing industry there. Okay? So what can we do about this? Well, I mean, the number one thing is to not use as many fossil fuels. If you don't burn the coal, you're not going to release the sulfur. If you don't burn the gasoline, you're not going to release the nitrogen. Or if you burn less, you'll release less. Okay? Have higher efficiency engines to burn less fossil fuel. Okay, I mean, that's the number one obvious choice. But, I mean, that requires some pretty serious changes in our economy. So, what else can we do? Well, we can install scrubbers. Okay, a scrubber is what this shows. These are installed on smokestacks in, say, coal-fired power plants. In fact, they are now required on all coal power plants. Okay. And basically what it does is it absorbs the sulfur. There's limestone in there that absorbs the sulfur before the smoke can actually come out the top. Now, they have to be cleaned. They have to be replaced regularly, and it can get to be expensive. But the regulation is such that if you don't have one of these scrubbers installed, the fine is enormous. The penalty is much more expensive than the cost of the scrubber. So every coal-fired power plant, every steel mill, every major heavy industry that burns coal has scrubbers installed. Okay? In cars, modern cars, ever since the 80s, I believe, maybe even before that, have needed to have catalytic converters installed. They are required on cars and trucks. If the catalytic converter is removed, and this is found out, there's a huge fine for that. Okay. In some counties, actually the county I live in, Porter County, vehicles need to pass emissions tests in order to renew the registration on the vehicle. It has whether the county has to do it or not. It depends on the population. But every couple of years, I have to bring in my car. In order to renew the registration, it has to be hooked up to a machine which tests the gas coming out, or the exhaust gases coming out of the tailpipe, to make sure that it passes. If it does not pass emissions, then I have to bring it in to a repair place and have the emission system fixed up, including the catalytic converter. And if it's not done, then I can't renew my registration. I can't get new plates. Okay. These can be expensive. A catalytic converter has a small amount of platinum in it, which is extremely expensive. I mean, it's a very small amount, but still, it's expensive. Okay? But the effect is that it greatly reduces nitrogen oxide emissions. Okay? Some people, they modify their vehicles. They think it makes it higher performance. They call it straight piping by removing the catalytic converter. It does not actually increase your performance at all. It just makes it produce more emissions. A long time ago, the very first catalytic converters sometimes did reduce the performance. It kind of choked off the exhaust, so people would try to remove the catalytic converters. Modern catalytic converters don't have this effect. Removing it doesn't help the performance of the vehicle at all. It just produces more pollution. Okay, now cap and trade. This is a big thing for coal emissions. This was a thing established in 1990. It set this cap, a maximum total amount of sulfur emissions that are allowed to be released in the entire United States. Currently, that cap is 8.95 million tons of sulfur oxides can be released into the atmosphere every year. Okay. And then that 8.95 million tons was divided up among all the different power plants, steel mills, everything that uses coal. Okay. And these are called allowances. So one allowance is permission to emit 1 ton of sulfur dioxide per year. So a big factory might have thousands of allowances. Okay. A small place, maybe only a couple. Now, these are, you could buy them, you could sell them. Anybody can buy or sell allowances, or you can buy extras if they're cheap at a time and save them for the future. Okay. The EPA, the Environmental Protection Agency, can buy them back and then can sell them off to raise money. Environmental groups can buy allowances and then just hold on to them. If an environmental group buys allowances and then doesn't actually burn any coal, doesn't release any sulfur, then that's just, out of that 8.95 million tons, that's some amount of allowances that are just not allowed to be released at all. Now, there's a financial incentive then to become cleaner, because if you're a cleaner power plant, burning less sulfur, burning less coal, you don't need as many allowances. You can install scrubbers, you can use other fuel sources. And if you're a very dirty power plant releasing lots of sulfur, then it costs you extra money. You need to buy more allowances. Okay. So let's say we have two companies, one that owns 5,000 allowances, but it only actually emits 3,000 tons. It's cut back. And another company that owns 6,000 allowances, but they've gotten dirtier. They emit 8,000 tons. Well, the first company can sell 2,000 of their allowances to Company B. Company A makes some money. Company B has to buy these allowances. If they don't have enough allowances, if they only have 6,000 allowances, but they emit 8,000 tons, then they get slapped with an enormous fine. So the overall result is this huge reduction in emissions. Currently, sulfur dioxide emissions are less than half of what they were in 1980, which is especially awesome considering how much the population of the United States has increased in the last 40 years. And if you look at this map, this shows the amount of acid rain, okay, how much sulfur in the atmosphere, and therefore how much acid rain fell in the late 80s, early 90s. I mean, you could see where it was the worst versus where it was even more than 10 years ago now, in 2007 and 2009. Look at how drastic that reduction has been. So when I say that this is something that gives me a lot of hope, well, this is why. This is an environmental problem, a massive environmental problem that we actually fixed. Just so you know, the price of allowances varies dramatically. They're traded on the market. They were about $200 in 1999. They were $883 each in 2006. In 2011, they were $2.81. Currently, they cost 4 cents each because of new technology and because now lots of places use natural gas instead, which is cleaner, which is great. All right.